Okay, in this video, we're going to solve this problem right here, and so let's begin. So first, what I like to do is just plug in. So x is approaching 0. Problem is, if I put a 0 right here, 4 times 0 is 0, and so we're dividing by 0. And that's a big red flag that you have to approach this problem differently. But let's even be more specific. Let's also tackle the numerator. So 6 raised to 0 minus 5 raised to 0. And we already said the denominator is 0. Now 6 raised to 0 gives you 1. 5 raised to 0 also gives you 1. So we have 1 minus 1, which is 0. And so we have 0 over 0. And because we have 0 over 0, we can use L'Hopital's rule. And so we're going to take the derivative of the numerator and the derivative of the denominator. So we have the limit as x approaches 0 for the derivative of the numerator, so 6 raised to x minus 5 raised to x, divided by the derivative of the denominator, which is 4x. Close parentheses. And now let's continue. So we have the limit as x approaches 0. Now we take the derivative of 6 raised to x and we take the derivative of 5 raised to x. So the derivative of 6 raised to x would give us 6 raised to x ln parentheses 6 minus this piece right here. The derivative of 5 raised to x is going to be something very similar. 5 raised to x ln parentheses 5 close parentheses divided by, we take the derivative of our denominator, and the derivative of 4x is just 4. And so now we can try plugging in. We'll plug in a 0 here, and so we would get 6 raised to 0 ln parentheses 6 minus 5 raised to 0 ln parentheses 5 close parentheses divided by 4. And again, 6 raised to 0 is 1, 5 raised to 0 is also 1, so we get ln parentheses 6 minus ln parentheses 5 divided by 4. And if you want to, be fancy, you could say ln parentheses 6 divided by 5. If you use your log properties, divided by 4. And this right here is your final answer, and that's all we need to do for this problem.